All right, guys. So we are going to just continue with this question. So we said that here we would have at the center x would be 2 times 47, and 2 times 47 would be 94. So x would be 94. Check that and make sure that the calculation is correct, guys.
Yes, sir, it is.
All right. So now, all right. So you don't have to, you don't have to do these answering in order. No? You don't have to do y next. You can just jump to z if you can figure out a way how to do z. All right, so can anybody tell me what z is? Let us leave y for a little bit. What is z? Let us go to y. What is y? Anybody can figure out what y is?
Sir, could we find the angle for y using angle at a straight line?
No.
Okay.
You remember the theorem that we were talking about, alternate segments?
Yeah, yes, sir.
Right. So you have to look carefully for them, because if you don't look for them, you don't see. If you
So,
have,
sir, we can farm out.
card here, you notice that card. All right. So I'm just trying to give you a sense of what you're looking at. You see, you have to be familiar with the theorem, and when you're looking at the questions, you're actually looking for the theorem that you know. All right. So if you look carefully, you will see the theorem stand out if you know what you're looking for. Do you see that that's angle within angle in alternative segments? Remember, this angle here is the same as the angle over here within the triangle. So this is actually 28.
Okay, sir.
You see that?
Yes, sir.
Okay. Now this one looks a little trickier than that one. How can we determine this? Why?
Sir, did I use the psyche something method?
Or the cycle lateral?
Yeah, it like one did it. Or
well, unless you had a straight extending from one side of the quadrilateral, maybe you could use it, or you could use it to find this angle here, because you know that these opposite angles would be, well, this is not a cyclic quadrilateral really now, because this side is not touching on the circle.
no, sir, I was referring to the line from touching, go straight up to 47, then come back down to that angle, then form that angle.
Right. So that you could look at that one too as well. Right. So so for this cyclic quadrilateral, you could use this angle to determine this angle, because these two, 47 plus this angle, all of this angle should be 180.
Mhm.
So this angle would be what? From here to here. What would that angle be? Subtract 47 from 180.
133, sir.
133. Now, this is 133. Now, the entire angle on this line, all of the angles,
Add up to 180.
right? So you know that this is 133, this is 28. So you can now calculate Z based on that.
So you get 19 for Z, sir.
Okay. Is that clear to you guys? Raise your hand if you are comfortable with this question, guys. Miss Green? Miss Green, I'm not seeing your hand. Are you not comfortable?
Comfortable.
Miss Green,
Sir.
are you comfortable?
Yes, sir.
Okay, all right, good. All right, let us see if we can see anything else that seems challenging. Would you be able to figure out what X is in that one, in this one? What would be the angle X here? Guys, are you hearing me? Can anybody figure out X? You have to use all the theorem that you know, guys. What do you know? What do you know, guys? You know that you have a tangent. This is a radius. So you know that this is 90. So you know that this is 90. What else you know? You know that this is 90 because this is angle within a semicircle. You know that this angle here must also be the same as X based on this triangle. So can we figure out what this angle is? Anybody? All right, think about it a little, guys. So they ask you to find the angle ADE, DAE, EAB. So all of these angles that you're supposed to find. Let us start with ADE. What is ADE? We have D. Let me see if that can come out. We have DAE. Any suggestion, guys? All right. Now, the question is saying, what the question is saying, you have to find in terms of X, meaning that you don't have any actual value for X. You just need to find these angles in terms of X. All right. All right. So in terms of X, angle ADE would be what? Anybody? All right, so if you take the line from A to D, take this line from A to D. These angles, the angle at D and C, they are in the same segment. You agree, guys? So this angle is X. So it means that this one is also X. The other angle, which other angle that we want? So that's angle AD, angle ADE, that's the first one. The other one is angle DAE. The angle DAE, this angle in terms of X would be what? What is this angle, guys? This angle would be 90 degrees minus X. You agree? Because this one is X, then this one is 90 minus X because of this triangle. Is that clear, guys? Guys, please respond. I can't make any comment if you're not saying anything.
Sir, which sector you're using, sir? The one from A to E? That is what they use, that card they use to divide both sectors?
Not sectors, segments.
So, yeah.
Right. So angles within the same segment on the circumference are the same. So this angle, if you're using this card from A to C to D, you're using the same card, and A to D to E. These two angles are within the same segment, right? They're using the same radius over here, coming back here.
Okay, sir.
So whatever angle form within segment will all be the same. If you're using the card A and D, so this angle is going to be X2 as well. All right, so for this angle down here now, we're using this right angle triangle that we know. So we know that this angle is X, so this one down here is 90 minus X. Follow? Is that clear? Guys? Miss Green? Come on, guys, let me get some response. Remember, we just look at right angle triangle. We say that if you know one angle within, apart from the 90 degree, if you know one angle, so if this is 10, down here is 90 minus 10, Remember, guys, complementary angle, we just go through it now. So follow?
Yes, sir.
So it's the same principle. If this is x, down here is 90 minus x. This angle within the right angle triangle is 90 minus x. So that's a principle. Turn out here now, we're using angles within the alternate segment. So on this side of the card, you have x with the tangent line. And in this side, we have x within the triangle that forms from here. So this is the alternate. So this is also x. All right, let us see which other angle that they want. So the angle EAB yeah, that's the one that we just look at. EAB would be X, alternate angle. And the angle AOE, what would that angle be? Let us draw the line that's necessary here. The angle AOB. That's what that one says. AOB or AOE.
It was AOE, sir, I think.
Yeah, AOE. So it's from A to O. And then to E. So what is the angle at O? That's what they're asking. Remember, that's what kind of triangle is that?
Isosceles, sir.
Right. So if that's an isosceles, that means this angle up here going to be
90 minus x as well.
Right. And then this angle in the middle, how you calculate it. Remember,
sir,
angles would have to add to give you
sir,
one.
would that be, sir?
Remember, all the angles within the isosceles would have to add to your 180.
180, sir. So it would be 90.
So, all right. So we say O plus these two angles, 90 minus x. So O plus 2 times 90 minus x. Sorry, guys. Sorry. So that would be 180. So we can just solve for x here now. I solve for O. Second. All right, so 2 times 90 would give you what? So that 180. And 2 times minus x give you what? Give you 180, right? So now we can bring over, we're solving for O. So you bring this over, that will be 180 minus 180. So you have O minus 2x will be equal to 0. So O, remember this is O, guy, not 0, guys. So O would be equal to 2x. So this angle here is actually 2x. Okay, guys. Raise your hand, guys, if it is okay. Guys, if you don't respond, I'm going to take it that you don't understand. So Ms. Green, are you clear on this one? Mr. Lamar, are you clear?
Yes, sir.
Okay. Moving on, let us see if we see any more that are interested. Look at this one quickly. What would be X and Y? Guys?
Sir,
Yeah.
for one we're seeing two isosceles triangle, right?
Well, not necessarily.
So X would add up to 180 with
It
input would
could
add up to
be,
90 with the other side.
yeah, it could be two right angle triangle, no? And it may be correct this way some. But what would you use to make that assumption? So you have to give a reason. You have to give reason for your answer. You can't just guess it and then if you guess it, if you are to get 2 marks, you get 1 mark just for guessing.
Sir,
Yeah, go ahead.
sir, I'm saying X and Y is 45 degrees.
Yeah, they're actually 45 degrees. But why?
Sir, because I second quadrilateral. Because two angles in a semicircle is 90 degrees. So the angle at C and the angle at A are 90 degrees.
Good.
So
that means this is 45, this is also 45.
yes, sir.
Sir, looking at it from the isosceles property same way, so it would work out to be the same.
Yes, it would have, but you have to justify your answer.
Okay, I see.
So it's not whether or not you're just correct, because some of, if you notice, some of these they will ask you to give reasoning.
Okay, sir.
Before you get the answer correctly, you'll only get marks for just the answer, but you won't get marks for the reasoning.
Okay, so in this case, it would be best to use the cyclic quadrilateral.
Well, it's not just say best to use a cyclic quadrilateral. You could say that it is isosceles, but you would have to say why. You follow? So you
Yes, sir.
the argument of the angles in a semicircle equal to 90, So you could say since the angle in semicircle BCD is 90 at C and 40 and B is 45, therefore X is 45. Hence, this would be an isosceles triangle because the two base angles are the same. 45, right? So it's really in that case, what they're doing, they're checking to see whether or not you clearly understand why you're giving that answer. That's why they would say most of the time they say that math is about reasoning, and reasoning is about saying why. So you,
Okay, sir.
you tell why you get your answer.
Okay, sir.
All right. All right, so there's a calculate. All right, see it here, calculate given reason, the value for X and Y. The other part now says that show that ABCD is a square and give reason. Why would it be a square?
They're all cards equal. Looking at the card. Going around.
Well, you may have a rhombus with all the sides equal and it's not a square. So you could use that argument. Even though a square has all sides equal, you have other shapes that have all sides equal, which are quadrilateral too, but they're not squares. So you have to keep.
Okay, sir.
So which other property of square that you would have to apply? What is the measurement of the angles within squares?
90.
90 degrees. So you would have to use that property. So all the angles at A, B, C, and D are all 90 degrees. So that's one of the property of a square. So you have all sides are equal and all angles are equal to 90 degrees. All right. Look at this one here now. What they want. All right. These are the angles down here that they want you to find. OLQ, NQP, NLP, NPL. Start with OLQ. So O, going from O, L to Q. All right, let me just use a line to highlight what they're asking for. So they're going from O, L. I remember that the angle, once you're doing angles and they're describing it using 3 letters, the angle form at the middle letter. So wherever the middle letter is, that's where the angle is. All right, so what's the angle here, guys? You have to try to look at all different things within the triangle. And sometimes you need to, like here, they don't put a dot here at O. You're not sure if O is the center. So what you could do is read the question and see if they tell you that O is the center. And if they tell you that O is the center, then you know that even though there's not a dot here, because here they have with center O, so it means that you can actually put the dot here to show that that is the center. So sometimes they need to read the question and pick out from the question what is not given on the diagram. Because sometimes things are given in the questions that you don't see on the diagram, or they don't put it on the diagram. So with that said now, you know that O is the center. What can you use now to determine the angle at L? You have another angle that you can use to help you out, guys. You know this angle is 64. So what's the angle here?
64 as well, sir.
64 as well. And so you can find this angle, because you know that if you have all of these angles added together, if this is X, this is also X. Well, all of them added together would give a 360, right?
Yes, sir.
You could find X here, and you know that this is an isosceles triangle, so you could find this angle, because these two angles would be the same. So how to do that now? You would say 64, or if you want to say 2 times 64 plus 2x is equal to 360. So 2 times 64 plus 2 times x equal to 360. You can find what x is. 2 times 64 is what?
128, sir.
So that means 2x is equal to 360 minus 128. What I get?
232, sir.
232. And that means you can find x by dividing both sides by 2. So x is equal to what? 116.
Yes, sir.
All right, so if x is 116, you know that these two angles, say y, because this is an isosceles triangle. So you know that when you add up all of these in this triangle, you must get what? 180.
Yes, sir.
So you can say that y plus y plus 116 give you 180. So 2y plus 116 equal to 180. And we want to solve for y because this is just what you want to know. So you want to subtract 116 from 180, you get what?
64, sir.
64. So y equal to 64 divided by 2, which is 32.
Yes, sir.
So it means that that angle there would be 32. So that would be the angle here. So that's the first angle. Is that clear, guys? And sometimes you may have more than one way to arrive at the same answer. So even though I might see this way of doing it, there's a possibility that there could be another way. You following, guys? So it doesn't matter if you find another way of doing it. It just means that that's a way that jumps out at you. All right, so moving along. Let us see what other angle we need to find. Bear in mind that that angle L is 32. So the other one is NQP. So the angle NQP. That's the angle that we're looking for. Can anybody identify what that angle is supposed to be? Remember that this angle is 32. And because it's an isosceles, this angle is also 32. We know that this angle here is 116. So these are what we know from calculation already. Now, what can you pick up anything from this angle?
Sir, the answer
What?
would be, so for angle Q,
Yeah. N
the answer would be 38.
with NQP, you can't just say angle Q. You have to say angle N.
Okay, so it's NQP.
Right.
All right, so 30 degrees.
All right. So why would it be 38?
Sir, because angles in a semicircle add up to 90 degrees, and you already have the 32 and the 20, so you add them, subtract by 90, and you get your remainder.
Good. Everybody see that? So this angle within the semicircle. So what Mr. Lamar had just pointed out for us is this triangle in the semicircle. We know that's a right angle triangle. And the angle here, the angle here to there must be 90 degrees. So we know that this is 20, this is 32. So we add these two, 20 plus 32, subtract it from 90, and you get 38. Everybody see that? Everybody see that, guys? Raise your hand if you're
Yes, sir.
following, guys. All right. All right, so let us see which other angle that we need to find. All right, so the next angle we want angle NLP. So the angle N